Welcome to the 16th lecture of Logic and Distributed Control System. Today we are going to discuss about the PLC data move systems. So objectives are, at the end of this chapter you will able to describe the move function. You can apply the move function to industrial problems in combination with other PLC functions. Describe the block move function. Apply the block move function to industrial problems in combination with other PLC function. Describe the table to register move, which is indicated by the command tr, and the register to table move, which is indicated by rt function. And also you will apply the tr and rt functions to solve different problem. So as an introduction, all computer systems including PLCs have the internal ability to move data, numbers and bits from one location to another during computer operation. In smaller PLCs, the moving of data from one register to another internally carried out automatically. The movement of data takes place, but we cannot monitor or control its operation. In medium size and larger PLCs, programming functions are available to control data movement. The PLC's programmable data moves the PLC's programmable data moves data from one place and move it to the another. This chapter explains three types of these data moving programming functions. What are they? First, the chapter covers with a basic system of moving one register's content into another registers. So we have one register, suppose it is 16 bit, so that contain how we can move to the another register. The basic move function takes a word, byte or group of bit pattern from one place and move it to another. Some PLC system use get or put format instead of move, but we will use move. Second type of PLC data move involves moving groups of data from two or more consecutive registers to two or more other consecutive registers. The second type is usually designated as block move in PLCs. It moves a consecutive group of registers data patterns to another consecutive group of registers. Some PLC formats call this file to file. We will use block move. The third type of data move involves two subsets. One type sequentially move data from designated group registers to a single register. This is called table to register move. The other subtype takes the data value from a single register and move its value, which is normally varying sequentially to a portion of a table. The sequential moves are often at designated time intervals. This is called register to table function. In all moves, the contents of the original source registers are retained. You essentially then duplicate the source register's value to the another register. Conversely, the designated register where you are going to transfer the data, which receives the duplicate new data, loses its previous value. If you wish to keep its original value for reference, additional programming is needed to duplicate and store it elsewhere before to move. So now we want to understand the PLC move function and its application. Figure shows the elements of move function in block and in coil format. We discuss the block format in this chapter. So this is the block format and this is the coil format. So block format, you can see that here the enable input is indicated by IN19 or enable switch, and it having two important things. One is source, another is destination, and the operation is indicated by a coil which is indicated by MB63. So MB indicates the move operation. Okay. So when the function is turned on through the enable circuit, the bit pattern from specified source register is duplicated in the specified destination register. The source register is unchanged. the destination register pattern is replaced and lost when the new value is brought in. So whenever this IN19 is energized, then the source register, that is content of the source registers which is in the IR107, will be copied to the destination registers, that is OR, output register. So IR is indicating input register and destination is the output register OR 1123, and this the data will be retained. So the data which is copied from the source register, it will be retained, and the data of the destination registers will be replaced by the new data or new data content of IR107. Fine. Now that's why the source register is unchanged. The destination register pattern is replaced and lost when the new value is brought in. The function coil goes on when the move function is completed. The coil operation can be used to interlock move function when there is more than one move function in the program. Okay, we will shortly see how the interlocking we can do with the move function. Why the interlocking is required? Now, interlocking prevents energizing two or more contradictory moves when only one is desired. For example, two moves to the same registers cannot take place at the same time. To avoid that condition, we should use the interlocking characteristics. Okay. So now the types of registers that are accessible by moves vary among PLC models. Source locations are generally the input registers, output registers, holding registers, or internal registers. Sources also include output and input group registers. And destination locations are the same, except that input and output register groups are usually not available as destination. Okay, so destination locations also may be the input, output registers, holding registers, but except that the input and output registers in group are usually not available as destination. In the timer program examples, all use constant value numbers for the time interval. Means the preset value we have observed that is constant, but it may happen that it will vary over the time. How we can do that one? Using the move operation. In PLCs, it is possible to use a register's numerical content for the timing interval, for the preset value. For this situation, the numeric value of the holding registers is specified as the time interval in the timer functions block. It is often necessary to quickly change the time interval of a process timer. We can accomplish the change by varying the numeric value of the timer's time interval holding registers with the move functions. Okay, here you see how we are doing that one. Suppose in an application that two different timers times we require, that is 7 and 15 seconds. Okay, so the figure shows the application of the move functions where either of the two values of time may be moved into the PLC timer. The two different times, that they are the 7 and 15 seconds, and either time may be entered into the timer by closing either input switch of IN7 and IN9. How? You see here we have used the two move function. In a move function, suppose HR51 which is written, let me little bit yes, now you can see that here move function 1, that is move 71 and move 72. Now you see the contents are very important. Source is HR51, which will contain the 7 second, which is written in the binary, and because it is 16-bit long, and the insert 15, that is also inserted in another source register, that is IR52. Fine. And it having the individual enable line, that is IN7 and IN8. And most interesting thing is the timer. The preset value is not constant, what we have seen previously, but instead of that, it is the address of the registers, that is HR101, which is the destination registers of the move function 71 and 72. And to avoid the avoid that at the same time we should not move the data to the same location or same, that is HR101. We have used the interlocking, means whenever the IN7 is working, okay, at that time we have used as a enable normally close MB72. okay, whenever it is in use, then what will happen means whenever we are transferring the data from here to here, then what will happen if it is normally close MB72, then it means that as long as it is de-energized, then we can have the data transfer from the HR51 to the destination. Okay, similarly we can see that we have used as an interlocking MB71, which is the address of the first move. Okay, and now what will happen that if you enable that IN7, okay, and if you want that 7-second will be the preset value, then the 7-second will be inserted, and if you want that the 15-second will be the preset value, then you will energize IN08, then you can transfer the data that is the 15-second to the preset value, that is HR101. okay, and to have the timer, you know that you have to on the enable, and then to run the timer you have to close the IN009. So in this way the move functions can be used to insert different values of the different value of the preset in the timer. Okay, so this is the way we can use the move function. Now another application we will see, that we will give a second example of single register moves, and this time using an addition process. Suppose that the PLC add function can operate only with holding registers as operands. Suppose also the numbers to be added enter the PLC into the input registers, not the holding registers. Okay, so then it is required to transfer the data from the input registers to the holding registers, because the add function can add only with the holding registers. So furthermore, the result of the addition is to go out from the PLC into the output registers. Okay, so whatever the data means addition result you are getting, that need to be transferred from the holding registers to the output register. So PLC data moves are therefore required to accomplish the total register configuration. And figure shows a register destination, that is register designation problem in block diagram form. So let us try to understand what we want to do. So we want to have a addition operation, but addition operation only have the HR142 and HR143, where it will add and the result will be stored at HR144, but the data will come from the input registers, and it is also changing, means we want that that the data may come from IR41 and IR42, which has to be added, and the value of the addition which will be stored HR144 has to be transferred to the OR output register 6. And if we add the IR51 and IR52 content after addition, then we have to transfer, means first of all we have to transfer the data from HR51 to 142, HR52 to 143, and then the addition result will be transferred to the OR7. Similarly, what I told, that the content of the IR41 has to be moved to 142, IR42 has to be moved 143, and then the result which has to be stored in HR144, the value has to transfer to output register 06. So how we will accomplish this using PLC ladder diagram. So let us do that one. So here you can see that we are using actually 4 move functions. So MB151, MB152, MB153 and MB154. Okay, so first set, you see first group, that is source registers is IR41, but the destination register is HR142. So now if the move function is energized by IN7, then the content of the source register IR41 will be copied to HR42. Then similarly, if the IN7 is also energized, because this has to be energized simultaneously, because these are the two data we want to transfer to the addition, to perform the addition operation. So here you see one adder block also we have used, but mind that the operand 1 the address is HR142 and the operand 2 having the address of HR143. So whenever these are two energized, then the data will be moved to the HR142 and HR143. And then if you want to perform the addition, then what you will do, you will energize this IN010. Then what will be the addition operation will be performed, and the addition result will be stored at HR144. And then what you can do, that if you energize IN17, then the source, that is HR144, the data in the source register 144 will be transferred to the designated register, that is OR6. Similarly, other group will be, and to avoid the confusion that which data you want to move or which set of data you want to move, we have used the interlocking, that is IN8 normally close, which is the switch for the next move functions. And similarly, that IN7 means whenever the IN7 is energized, then this move function means another move function is by 153 and 154 cannot be done. Okay, to do the next set of operation, what you will do, you have to energize 108 and IN108. Whenever the 108 will be energized, then this move operation will be disabled, and then you have to perform with this operation. And you see it is IR151 is the source and IR152 is the another source of the another move function, but their destination is very important, that is HR142 and HR143. So once it is pulsed, then what will happen, that add function, in an add function the operand 1 will be the content of HR that is IR51, and the operand 2 also consists of the data of IR152. And then if you again energize IN010, then addition operation will be performed and the result will be stored in 144. And after doing this operation, if you again energize the IN16, and if you energize the it is IN18, and then if you energize IN18, then this move function will be disabled, and then what will happen, that the source registers, that where the data means the addition result is stored, that is HR144, will be transferred to the destination register, that is OR7. So this is the way it is going to work. Then moving large blocks of PLC data. So it is sometimes necessary to move data in a group. One option is to use a number of individual move functions. A better solution is to use one PLC function that will move many consecutive registers data at once. These are called block transfer functions, BT. Okay, suppose we need to move 147 bits from one location to another but have only 16-bit registers available. So we need to use 9 full 16-bit registers. So 9 into 16, it will be 144, but we have to transfer 147 plus part of another, that is 3 bits we will use. So total we are using 10 number of 16-bit registers. So in this case, one block transfer function does the work of 10 move functions. So figure illustrates the BT function, how it is going to work. Okay, so here you can see that you have the content. Let me magnify this. Here you see, here you have the 10 registers, that is IR53, IR54 to IR62. You want to transfer the data of this 10 register to another set of registers, that is OR128, OR127 and OR that is 137. Okay, So now how you are going to do that one using BT function. So here you see this is the way you can do, that is this is the enable IN7 and this is a BT173 is indicating the coil. So coil goes on when the data from all 10 registers is transferred. But how you will define the operation? So first of all you have to indicate the length is 10. It means that we want to copy the content of the 10 registers. So now source end. So once it is length 10 and if you indicate the source end IR62, then this is specified, and then the last 10 registers will be specified, okay, by indicating the source end, and the destination is OR 137. And you can see that once it is 137, so here actually it will be 128, it will be 129, okay. So another 9 registers will be specified by this length, okay. So let us see how it is going to work. So in the functional block, specify the number of registers to be moved. Also specify the last registers of the input sequence from which the data comes. Finally specify the last register of the destination register sequence where the data is to be delivered. As usual, the enable input causes the data to be transferred. The output coil comes on when the transfer of all registers is completed, okay. Now we are going to discuss another two data move functions, that is PLC table to register moves first and then register to table. So in the two move functions described earlier, we first move data from one register to another register. When we move data from one consecutive register group to another consecutive register group of equal length. A third type of move involves that involve the tables and a single register. So the table to register, which is indicated by TR function, moves data sequentially from a specified portion of a large listing of data to a single register. Conversely, register to table RT function moves data sequentially out of a single register into a specified portion of a table of registers. Okay, so now first function we are going to discuss, that is TR, table to register. Okay, figure shows the block diagram from how TR function moves data. So let us magnify it and see how it is going to work. Okay, so here the we want that the content of these 4 registers, OR34, OR35, OR36, then OR37, we want to transfer sequentially the data to a single designation register, that is HR172. Sequentially we want to transfer, okay. So then this basically table to register T to R we want to perform, okay. So how we can do that one? Now it is telling that in a typical application, the receiving registers operates a number of machines by bit picking, which we will discuss later on, how this kind of operation will be useful for a bit picking function. As different table registers patterns are moved into the receiving registers, the machine on-off patterns will change. Means suppose the content of the HR172, the pattern what will be saved in HR172 is going to control the 16 machines, and the pattern that is 1001, like that, the pattern is going to control the machine state like on and off. And periodically you want to change the sequence of this operation by specifying the registers content OR34, 35, 36, 37, and periodically you are going to transfer the data from here to here to change the bit pattern HR172, and using bit picking function the corresponding machine is going to change its state. So in that situation, this kind of things or this kind of operation will be very much useful, okay. So A typical PLC function used to accomplish TR moves as shown in figure. So this is the TR moves. It is very important to understand the switches and the things you have to specify. You can see that we have to specify the length of the registers or table, that is here 4 number of register content we want to move to a single register. Then end OR37 end it, and if the length is 4, it means that 37, 36, 35 and 34, these 4 contents has to be transferred, and then pointer has to be mentioned. Pointer will tell you that in which location the transfer is going on, and the designation where actually you are going to transfer the sequential data from one register to another. Okay, so that's why it operates similarly to other move functions. The TR function is first programmed for the table length, as I have said, it is 4, which is the number of registers to be sequentially input. Okay, in this example it is 4. The second line in the TR function is the point at which the table transfer operation is to end. Okay, for example, the specified table length in this case is 4, and the specified end registers, that's why IR37. The table of register utilized runs from IR34 through IR37. The third program input is to the block is the pointer location, that is here HR100, it has been shown. Okay, found in many but not all PLC's RT and TR functions. The pointer is used to point to the register being moved at any given moment. Okay, the pointer location can be used for information or for control purpose. Finally, a single destination for the successive data values is specified as a fourth input to the functional block. So where to transfer? So how it is going to work? Now the function, when the function is enabled when the lower input line is on, so 79 if it is on, now the function is enabled. When the middle line, that is reset, is off or turned off, the function reset to the first register. Okay, the operational pointer, if included in the function, is also set at the first registers when reset is off. When the reset is on, the function is operational and can be stepped. Okay, so now if it is on, then it is ready to step from one register location to the another location. Okay, and then the top line is the step line. That is very important here. Step line means here actually this IN77 should get the pulse, okay, for a particular time duration to transfer the content of one register to the another register. Means here actually to do the operation, to transfer the content of 34, 35, 36, 37, it should get first pulse to transfer the first content, then again another pulse that you can transfer, and then it should get another pulse, third pulse to transfer the OR36, and fourth pulse to transfer the 37. And the time duration you can decide by the timer application. We have already understood that how to create the short pulse for at a regular interval of time using the timer that we have used, and you can use to create the pulses, short pulses at a specified interval of time using timer. Okay, so the top line is the step line. Whenever the step line is turned on, the function transfer data and moves down one register. The step to step, again the top step line must be turned off and back on. For time interval operation through the table, a timer can be used to do the stepping. A timer contact would be used as the step contact for the function. Okay, so timer, if you use the timer, and this IN77 will be the timer address or timer coil basically to get the pulse at a specified interval of time. Okay, now we are going to understand that register to table function. Okay, so register to table function is similar to the tr function. It moves data from single register sequentially into a specified number of consecutive registers. A block diagram is something like this. I can magnify it. Here you can see that we have the specified source registers IR 173, and in a step, suppose we want to transfer the content of HR 73 to the three registers, that is 162, 163 and 164. So these are the destination register 3 specified. Okay, so now in this situation, if we want to perform this, then how we can do that one? Now the programming of RT moves similar to the programming of TR moves. The input lines operate in the same manner. So here the step, reset and enable are the input lines. It is same like table to here register to table, and we have seen that one for the table to registers. Okay, the RT function is shown in figure. The table length denote how many designated registers are to be used. So here for this example we have taken 3. So then we have to mention the table end. Okay, so in our example you see it is 164, and if it is length is 3, so it means that automatically when it is falsified, you will find that it will go that over 164 to 3, 163, then 162 subsequently. Okay, sorry, here actually whenever your 164 is specified, so it will start from 162, then it will come to 163, and then it will come to 164. Okay, this will be the sequence. Okay, so the table end is the last destination register to be used. The pointer in the RT function operates similar to the pointer in the TR function. The source in the RT function specifies the one register from which the data is to come. Okay, so what is the use of this concept? The RT application might be the periodic recording of data. Okay, a single register could be programmed to indicate the value of a varying process parameter. So suppose your measurement value periodically changing, and you want to store whatever the periodic data you are getting to the different location of the registers. Okay, such that later on you can access for the plot or something. The single register's value is constantly changing as the process changes. The register is used as the source to record its value every 10 seconds for 5 minutes. Okay, we need 6 times 5, that is 30 registers to record the required sequential readings. The function step line is pulsed every 10 seconds. The table destination lengths need to be 30 registers, and the 10-second interval results are then recorded in order. The 30 sequential values appear in order in the specified series of 30 destination registers. So this will be the use of register to table function. So I will end here, and thank you.